So, welcome everyone for our 29th office hours. And today it's an exclusive session which is Zero G Storage 101. So, this section is exclusively for us and for the audience to learn more about Zero G's architecture. Why do we need a decentralized storage? How is Zero G unique compared to the rest in the market? And how you can get started with developing using our Zero G starter kits, SDKs, and much more cool stuff, which we have a super exclusive and a dear friend of mine, Uday Kumar here. He's a technical developer at Zero G, as you might have seen in the tech chats. So he will be explaining us more with this presentation and will also give you some insights and sneak peeks into the starter kits. So Uday, welcome to this session, and we are glad to have you here today. So please feel free to kick off this session and take us through this presentation. And before we get started, as Jan mentioned, we have like cool whitelist spots for the audience who have like the most interesting questions throughout this presentation. So looking forward to answer your questions as well as to pick the raffle from the audience. So let's get started.
Yeah, I'm just getting boosted. So yeah, I think that's a great one. So I'm also interested for the questions that it to come. So thank you, Gatin, for the introduction. Hey, Zero GM guys. So let's just dive into the things. So yeah, the main thing for this presentation is in next 15 minutes we are trying to explore the Zero G storage. That's a core part of Zero G ecosystem. We do have multiple AI projects that is in our ecosystem. So Zero G storage is the core part of it. By the end of the presentation, you will understand why Zero G storage brings what to the AI ecosystem. So it's a truly decentralized and a AI focused project. And many of us can question why the storage and AI can relate. So it's nothing to relate that, but I'll come to the question at the end, I think. Yeah, let's just get started, I think. So before the solution, I think we can start with the problem. Why the decentralization comes into the play. So let's start with the centralization. So what's the limits of centralization? So we know we do have AWS, GCP, Azure, Cloudflare. There are multiple plenty of providers who provide storage and other options into the stream, but still we do have many problems that is faced by many companies. So let's take an example. When the AWS went down in 2021, it's a major outage. After that also it went down, but it is regionally. In 2020 down 21, when AWS has some major outage, Netflix, Disney Plus, and other millions of sites has taken down. And when a Cloudflare went down, we do have multiple DNS issues that is coming into the thing. So the first problem is the single point of failure. Whenever these kind of guys goes down, everyone bring everyone with them. So that's the core problem with the centralization because they do have single point, single data server. If anything that happens to us, everyone is washed out. So I think that's a major no-no. So, and the second thing is censorship vulnerability. So it is based upon the region that is in and current political situation. I think this is more interesting because every day a geopolitical scenario is changing due to new Trump administration and everything is changing quite quickly. So I think this is a quite new part in into this equation and this is more to be seen in the future. And the third and final and a major issue, the scalability issue. So when it comes to the scalability, whenever the cost scalability increases, if someone tries to go to the AWS and create a site, they give it for free. But when the scalability sizes increases, the cost increase with that exponentially. It's not linearly. It needs to be expanded linearly, but they are just juicing up when they are scaling up. So that's not fair when it comes to scaling up the project. So, and we do have multiple set of investment that is coming into the play for the centralized things, and there is no I would say a hardware investment that is right away, because you could have known Project Stargate and many nuclear powered data centers are coming into play to support the AI need that is coming in the future, both for the storage and also for the GPU compute efficiencies. So, to tackle that, the centralization will not be a solution because it will cause the single point of failure and also the censorship vulnerability, and also causes the scalability issues. So, there comes the decentralized solution. So, before that, if a cloud storage goes down, a website will look like this. So, yeah. So I could call decentralized storage solution in two phases. There is a first generation of decentralized solution. I could say IPFS, Filecoin, or Wave. I think many of you could have heard that these names. IPFS is a common name. So it's the father of everything, I could say, because they started all of the thing, the decentralized storage. So it's a form of deep in, but it only focuses on the storage. So in first generation of decentralized storage, scalability is not focused, speed is not focused, cost is not focused. But whenever it is trying to improvise, they are trying to improvise the speed, they are trying to minimize the cost, and also they are trying to give the reliability when it comes to RV and those things. But they are compromising some things because they need to verify all the things into the chain. They are not able to get into it fully, but they have created a pretty much reliable solution to rely on. So when it comes to IPFS, the performance is averagely slow because the retrieval times are unpredictable. Sometimes it is normal, sometimes it is slow based upon the cache, the last time that we have retrieved the file. And when it comes to Filecoin, yeah, I think the speed is moderate, and they do have multiple things like FVM and multiple projects that is working on it. And the cost is normal. I don't say it is so high than the centralized solution that is given by AWS or GCP like S3 and the storage buckets. I think it is better than the centralized alternatives. And when it comes to RWave, it is slow. It is kind of a archival storage where you can store long time files, but it costs more because you are paying in single time. It costs really more because for 1 TB in Filecoin, it costs $80. But in RWave, it almost costs 17,000. So I would say when it comes to the AI things, you will need multiple TBs. So this will not be a viable option, I would say, and any company will follow that. Yeah. So to tackle this, I think we cannot move back to the centralized solution, but we need a decentralized solution to bring the make to bring our vision to life, make AI for the public good. So we need a decentralized solution. Also, it needs to be speed. Also, it needs to be efficient. Also, it needs to be cost efficient. So our team has worked on it and come up with a new thing. That is that is what the new AI demands. That is in the current hands. So when it comes to the data sets that is fed for a model, when we take common crawl examples, so that data set alone costs 100 TB, and Tesla's data set is alone 1.5 petabytes. And when it comes to model, GPT-3 is 175 billion parameter model. I'm not even getting into the 4o or other models. Even GPT-3 is more than 350 GB. And to stream this, we need to have a faster data retrieval rate, not like 1 Mbps or 0.5 Mbps. That will not sufficient for an AI workload. When it comes to the stability AI, they need a throughput of 20 Gbps to create the images. So if we rely on the IPFS to load, I think the loading will go, but will not be there. So that's not an efficient way to train. So our team come up with the zero G storage. So this is 40x faster than the IPFS and 500 Mbps consistent throughput. I think this consistent throughput word means even under the network congestion, we can able to give 500 Mbps. This is more than that, and this is the max for the IPFS. So ours is our average is the max of other first generation decentralized infrastructures, and our cost is really low, $11 per TB. When it compares to $17,000 for our wave, I think that is really cheaper than any centralized provider or decentralized provider of our time. So how we brought this horizontal scalability? So we followed these steps to bring that. So we have created dedicated flows. So every data that we want to store will have separate flows, and those data flow will handle different datas. So if you need specific set of data that needs to be retrieved fast, you can create a new flow and put the data into it so that you can get it efficiently and with chain verification. And our system processes each flow independently. So whatever congestion comes to a single flow will not affect any other flows in the system. And with the data increase, will also increase the flows. So there is no congestion that could happen here. Yeah, and for this architecture, I could I also need to mention two more things. So we are making it as a two-lane system. So the first one is the data storage lane. The, da- the data storage lane is responsible for getting the data and coding the data and storing it in the correct place. So we are following a technique called erasure coding. It is for redundancy. If take an example, we are uploading a file and it is going into the zero G storage system, and it could be splitted into multiple parts and stored in multiple places. Consider an example, it is stored in 10 places. Even if 5 of the node is down, we can able to bring the data. So that's the power of erasure coding. So our algorithm is efficient enough to split the data accordingly and store it efficiently across the distributed nodes, and we can able to retrieve it even if the nodes are down. So that's where we focus on the reliability and the availability part of the thing. And we do have the data publishing lane. So what this does is it mainly focuses on the metadata of the system. So whatever the file that you upload, all the metadata and the retrieval mechanisms and the verification will be handled by the data publishing lane. So the data storage lane will handle the data uploading and the erasure coding and the storage, and data publishing lane will handle the verification and the metadata. So since these tasks are splitted, it works efficiently. So our SDKs will remove these abstractions. So you can just call a upload method and everything behind it will be done for you. So nothing complicated required in that. So you can use it like the same S3 SDK that is available in the S3. So that's how our SDKs are designed. And when it comes to the data storage, I I need to say, so how the data is stored and how we can able to store it, because we do have multiple data storage mechanisms. Some needs object storage, some need kind of a KV store or log layer, or different kind of mechanisms, different needs for different use cases. So what we have done is, our main goal is to create a log layer. So log layer is a immutable layer. So whatever the data comes into the flow, it is getting appended into the flow. So there is no possibility of rewriting. So that's the secret sauce of why it is so speed, because we are not rewriting any data or indexing any data. It is just appended into the log. So everything is getting appended into the log. That is also accessible by SDK, so anyone can want to try it. You can create your own flow and append the data into it. Or if you want a reasonable key value store, that is also available and abstracted away into the SDK. So you can create your own keys and store your own values into the things. And we do have transaction layer, so where you can able to store the transactional data, and you can also able to upload the files and download the files. That is possible. And yeah, these things are abstracted away using our SDK. So currently we do provide SDKs for Golang and TypeScript. The TypeScript SDK is also compatible with working in the browser environment, so you can directly upload it from the browser environment. Like, you don't in S3 SDK, you need to create a pre-signed URL and send it to the front end, and then they need to upload it from the front end. But in our case, you can directly get from the user and upload it to the server. So you don't need the backend there. So the front end will handle all the thing. It will also improve the privacy of the user. So you can confidently say, I'm not touching your data with zero G's architecture. So yeah, and zero G always believes the decentralization and the true decentralization. We believe in the fair rewards. So not only giving the mining rewards to every bigger zero G storage users, what we do is, we created a truly decentralized environment where a small miner can also effectively get their profits. So if you want to run a zero G storage node, you can also start with 4 TB of SSD storage, and you can also run it profitably. You don't need to have a data center to make it profitable. Even from your home, you can able to run your zero G storage node, and it will be profitable. That's how the mining rewards has been designed. So when it comes to the mining rewards, I need to explain about the Pora. So Pora is the consensus that is powering the zero G storage. Pora means proof of random access. So how it works? So our main system will generate a challenge with respect to some time. So it will randomly generate a challenge, and it will share it with all the storage nodes that needs to solve the challenge. It is a challenge to identify a file, the system. It's not a full file, but what I would say is, it's a part of the file that is erasure coded. So the system needs to prove that they contain those data. If it is proved, they will be rewarded. If it is not proved, then they'll not be rewarded, and their incentive will be reduced. So that's how the Pora works. And due to this, we can able to also bring the consensus and efficiency into the system. Yeah. And I want to show you a chart. That's the cost comparison. I think you cannot able to find the line of zero G here, because so this is the cost comparison of storing 50 TB of data into any other system. So it is lesser than any centralized system and decentralized system. So with 0G, you can able to use the storage in a decentralized way, better than any centralized or a decentralized system, in faster manner, in an efficient manner, and in cost efficient manner. So let me summarize the things. So the 0G storage brings the speed and scalability using a multi-chain architecture that delivers the performance in a greater level. So it is, as I previously said, it is 40x faster than the IPFS and 1500 times cheaper than the RV. And we do provide the structured data support. So you do have log layers, you do have KVs, you do have object storage. So everything within a same storage system that is also decentralized. And that is the structured data support that is provided by 0G. And the cost effectiveness. As I previously said, it is cheaper than all the decentralized and the centralized storage system. Even it is 1500x cheaper than the RWave. That is one of the one-time payment storage system that is available as of now. And the AI readiness. Due to the horizontal scalability feature of the 0G storage, we can able to bring minimum of 500 Mbps even at the congested level. And it could go up to the Tbps level of speed. We can able to achieve this speed with the help of the data publishing lane and also the erasure coding technique. Since our data is stored in different places and it is fetched by this publishing lane, so we can able to retrieve it faster. So to get started, I think you can get onto the 0G docs page. And we do have starter kits that is created on the 0G docs page. We'll share all the resources after this call. With the starter kit, you do have starter kits for the TypeScript, Golang, and also Web Next.js. So whatever, you can just, you will have all the README documentation into it. Within 2 minutes, you will be get started with the 0G storage. You can even use it for storing your files, any files, or if you want to store your larger files in a cheaper rate, you don't want to pay to Google Drive or anything, you can even use the 0G. Let's try it out.
Awesome, Uday.
Yeah.
It was such a wonderful presentation, and it was so clear the way you started from the problems, the way you headed over to the solutions. And yes, coming to the conclusion, you did